Hey guys, we've been talking about graphing polynomials, and I want to go ahead and give you one example here about this unique situation. We're going to start looking at the end behavior first, and as you can see, this is a positive and it's x cubed, so it is going to go down on the left, and it will be going up on the right because it's positive. Okay, now that we have that, let's go ahead and take a look at our x-intercept. How do we find our x-intercept? Well, we set y equal to 0. And you guys know how to do that. Let's go ahead and y equals 0 here is 2x cubed plus 3x squared minus 8x plus 3. The only problem becomes in trying to factor this guy. It's a cubic. By looking at it, I can't take anything out, so it's going to be difficult. And let's see, the first thing I look at when I see four terms is factor by grouping, but we can't do that. So what you're going to have to do in a certain case like this, if you can't factor anything out, you can't factor by grouping, you're going to use synthetic division. Okay? Now synthetic division, hopefully you remember what it is. We're going to go ahead and try to take a factor and divide this polynomial. But the question is, what factors do we use? And that's where the rational roots theorem comes into play. Basically, what I'm going to do is I'm going to create a list of potential or possible zeros using the constant at the very end. I'm going to take the factors of positive 3, which would be plus or minus 1 and plus or minus 3. Then I'm going to also take the factors of the leading coefficient, and let me bring him around here, and he will be the denominator. So the factors of 2 are plus or minus 1 and plus or minus 2. Okay, now that I have that, my potential zeros are the rationals. Okay, basically the fractions. So 1 divided by 1 is 1, 3 divided by 1 is 3, and then the same thing, 1 divided by 2 is plus or minus 1/2, and then 3 divided by 2 is plus or minus 3 over 2. So these are what we call our potential zeros. Okay, potential or possible. We don't know if they are, we're just gonna have to test them out. Okay, so let's go ahead and test those out. Go ahead and test these out, and remember, when we write our synthetic division, we start from the leading coefficient in descending order, 2, and then we have 3, and then -8 for the x, and positive 3. Okay, what are we going to start with? Well, let's start with the simple one. Let's start with 1, see what that gives us. Bring down the 2, and then we are going to multiply. 1 times 2 is 2. 3 and 2, that's going to give us 5. 1 times 5 is 5, -8, and positive 5 is going to give me -3. 1 times -3 is -3, and if you notice, that's going to give me a 0 remainder. What does that mean? That means that this guy is a factor of the polynomial. So now I can go ahead and rewrite my polynomial. So this is going to be x minus 1, not x plus 1. It's a zero product property, so it's the opposite. And then we are going to write the remainder, the remaining polynomial, which is 2x squared, which is 1 less, and then plus 5x, and then minus 3. Okay, now we can go ahead and factor that sooner, or factor that some more, and let's put it over here. X minus 1, 2x squared plus 5x minus 3. Let me bring them here, and when you factor, you're gonna get 2x x. Okay, let's see, we want to get a positive 5. Factors of -3, let's see, 2 times 3 will give me 6, but I want 5, so this is going to become a -1, and that's a positive 3. So my factors in this situation, x equals 1, 1/2, and -3. Now what about the multiplicity? Well, at x minus 1, that's power of 1. At 2x minus 1, that's a power of 1. And x plus 3, that's also a power of 1. So what does that mean? That means all of these, remember Kobe, crosses when we have odd multiplicity. So the graph is going to cross at x equals 1, 1/2, and -3. So let's go ahead and take a look at see what this graph is going to look like. Okay, so let me get my zeros here in place. X equals 1. We're talking about this point right here. X equals 1/2, so probably right here. And x equals -3 right here. We know it's x cubed, so it's going to go down on the left, up on the right, because it's positive. Okay, and then what do I need? Well, we're going to use some test points. So let's see, what can we use? Let's go ahead and use -1. So f of -1, I want to see the value of the function when x equals -1, plus 3 times -1 squared minus 8 times -1 plus 3. So let's see here. -1 cubed is -1 times 2 is -2. -1 squared is 1 times 3 is +3. That will give me +8 and +3. This would give me 1 plus 8, 9 plus 3 would be 12. So the value of the function at -1 is 12. So if you can notice, this guy goes way up there. Now, we forgot to figure out the y-intercept, because I'm thinking if it's going to go up here somewhere all the way up to 12, I don't know, 12 maybe up here somewhere. The y-intercept. Well, how do I find the y-intercept? Well, we set x equal to 0. And if you notice, take a look at here. If I set this to 0, this to 0, this to 0, I'm only going to be left with +3. So this graph is going to cross right here. Okay? So you can pretty much give a rough sketch of what this graph is going to look like, going through here, through this point, and you know it's going to cross. At some point it's going to come up. I'm thinking not too much. It's going to come up and it's going to do such. Okay, so hopefully this helps you out, but I want you to understand, whenever you have this funky looking polynomial where it's long, you're going to have to use synthetic division by using the rational roots.